Hey guys, welcome to Deep Dive Coding. Today we solve a LeetCode problem of the day, and this is a very easy problem. So problem basically divide an array into subarrays with minimal cost. That is number 1. Okay. So in this video I will explain the first questions, then go to the dry runs with examples and build some intuitions to solve that problem, and finally to the code and complexity analysis. Complexity analysis consists of time and space. Now let's come into the question part. So there is a question given that we are given a nums array. So this is a integer, we are given an integer array, and we have to split this array into 3 segments, and each segments have the cost. So basically the cost is also defined as sum of each segment of the first value. That means let's break this whole array into 3 segments. We can break after here and here. So it's basically 3 segments, 1, 2 and 3. Now the cost equal to sum of first element of each segment. That means 1 plus 3 and plus 12. So if we break this way, then it will give you the cost of 1 plus 3 plus 12. So it will give you 16. But if we divide in another way, let's say we divide some another way. That you can say over here 3 and 12, and let's divide after 1. So it will be first segment this one, and let's second segment for this one, and this is the last segment. So this one first, second and last segment. So it will give you the cost of cost would be 1 plus 2 plus 3. These are the first elements, 1 plus 2 and first element 3. So it will give you cost of 6. We have to calculate the minimum cost. Now jump into the third example. This one is also given. So how we can divide this whole array into 3 segments so that cost would be the minimum, and cost would be the first element of the each segment, sum of the first element of each segment. So how you can divide? You have to, but you cannot arrange the array, like you cannot rearrange the elements inside the array. So you can do something like similar like this way, that first of all you have to okay, so you can divide this way, taking 10 as first element. So it will be the cost of 10, and plus you can divide over here, so that it will be 1 and 1 plus 1, and it will be the minimum. So I think you understand the problem. Now come into the constraint part. So if you look into the constraint is very low. That will like n, the value of n is up to 3 to 50. So that means there are at least 3 elements present in nums array. At least 3 elements is present, and at max 50 elements is present. Also nums I value go as max as 50. This is also quite low, and it's go from 1 to 50. Now let's dry run this example. Like you already understand our task. That means we just want let's say there is an array. Let's take this example, that would be like third example of here. So 10 3 1 1. So you can say this will be like 10 3 1 1. So if you look into this, we cannot rearrange the elements inside the array. So that means we have to take first element. Why? Because any segments we break, we have to this first element will be going to the cost of it. So like one element of the cost. So 10 is confirmed, and apart from that we have to pick 2 elements so that it will be give the minimum cost, and that 2 elements should be minimum. Like next from index 1 onwards we have to pick 2 elements which is smallest. as smallest as possible, and both elements should be different. That means in over here there are three elements given, 3, 1 and 1. So over here there are smallest element is 1, one is 1 and another one is also 1. So you can pick these two elements and add in the cost. So this will be the minimum cost. How? Because we are simply dividing this way, that's 10, 3, 1 and 1. So in the first segment we are taking this is as a segment, and this is the second segment, and this will be the first segment. So even if you look into the first example, that means let's okay 3, 1, 2, 3 and 12. Yeah, so let's take in 1, 2, 3 and 12. This example also given. So you can break, that means we are confirmed that we are going to take 1. Why? Because we cannot avoid from 1, that means the first element of the array. This will be the confirm. Now pick the next two elements which is smallest, that would be the 2 and next will be the 3. So the segment is divide 1 and another segment have 2 and last segment have 3 and 12. So the total cost would be 1, 2 plus 3. So it will give you the 6. Now we just implement this way, like this way, what we are already trying to do. So basically our main task, after this is confirmed that cost will be consist of first elements of nums array. So this will be the confirm. Now the next two elements we have to and let's say num as low num 1. Let's take variable of low num 1 and low num 2 to add the final answer. Now we have to over here you can say that 50 is already picked. Now you have to find the next two smallest element, so that would be the answer. Now how you can find that smallest element, different smallest element? So you start from you iterate from index 1 and go till next like end, go till end, and let's define low num 1 and low num 2 as maximum value as possible. Let's take an values of infinity and infinity, and in this case you can, okay, let's consider this is an infinity, and I value equal to 1 because we are processing from the first index onwards. So we simply check whether this element, this 1, is it smaller than num1? Yes, it's smaller than num1. So we simply update that num1, but before update that we just simply copy in the low num2. That means first of all we copy low num2 equal to low num1, that will be also infinity, and now we update the low num1 equal to 1, and we go to the next positions, that would be the third index, that will give you the 2. So now again you can check whether this 2 is less than low num1 is greater than this 2. No, it's not, because 1 is smaller. So you just simply go to the next steps and again check whether low num2 is be the greater than 2. Yes, it is greater, so you just simply update that thing, and similar way you just update, you just traverse through the whole array. So if you come into the, like, we are just find the pick the two elements that would be the minimum. So if you look into the code, I also do the same things as I already discussed, that low num1 and low num2 initialize at infinity. So why it's 100 over here? So as you look into the constraint, there are nums of I go as max as 50. So we can take any value, let's 51, any value above 50 that consider as infinity. So I take the 100 as an standard, not standard, you can say 100 is over 50, so it's okay. Now we iterate from index number 1, because index value 0 we already take that as an answer. Now we process from the index number 1 and go till end, and if each elements we are processing, so if low num 1 is greater than or equal to nums of I. That means whatever number stored in the low num1, that would be the greater than the nums of I, that we have the better choice in the nums of I. If this condition is true, we just simply first copy low num1 to low num2 and then update the low num1 to nums of I. And if it is not true, that means what, low num1 is already a better choice than the nums of I. That means nums of I is greater than low num1. So we can go to the next next conditions. This will be the else if. So if it is not true, that means low num1 is a better choice. So we just check the whether low num2 is a better choice or not. So low num2 is greater than or equal to nums of I. If it is true, then nums of I have the better choice for the low num2. So we can just update that answer. So after a whole array is traversed, we just add the low num1, low num2 and nums of I as a cost and return it. So I think it's very easy problem. And let's come into the complexity part. So if you look into the complexity part, we just traversing the whole over here. It will be take of big of n time complexity, and apart from that we are not taking any extra time. So it will be like big of n time complexity. And for the space, we are taking constant space, that is low num1, and low num2 is the constant space. So you can say that space complexity would be the big of 1 space complexity. Thank you guys, thank you for watching. Stay tuned for more videos.